This is section 4.3, day 2, polynomial division. And so we've got basically applications of the things we learned from yesterday. So the remainder theorem, for example. The remainder theorem says that, here's the kicker right here, f of c is equal to the remainder. If you really wanted to find f of c, if you wanted to plug a value in and evaluate the function, you could also just do the division and the remainder is equal to the value of the function. Let me show you what I mean with an example. Let's say you just had this really huge function like this, and you need to calculate what f of 10 was. Well, here's one option. You could do it like you normally would. You would just, f of 10 is equal to, my goodness, 2 times 10 to the 5th minus 3 times 10 to the 4th plus 10 to the 3rd minus all that. Who knows what that is? It'd take a while to figure it out. But there's an easier method. You can use synthetic division. The division comes from this theorem, says that if you took f, the function, and you divided it by x minus c, the value c is that would be the 0, then you would get f of c is equal to r. The remainder is equal to the same thing. So check this out. If you want to find f of 10, it's easier just to take the whole polynomial and use synthetic division on the factor of 10. So here's the 0, and then 2 goes down, and then multiply by 10, add, multiply by 10, add, multiply by 10, add, multiply by 10, add, multiply by 10, add. There it is. This is your answer. You can say that f of 10 is equal to this. F of 10 is equal to 170,802. That's because the function f of c, f of 10, is equal to the remainder, and this is what the remainder was. Here's another application. Determine whether or not 5 is a 0. Well, if you think if 5 is a 0, then we should get a remainder of 0 here. And in fact, we do. One thing I want to caution you is that we're assuming when we do synthetic division that we have all the terms in a row, and there's actually some missing terms. There's no cubic term, x cubed. There's no linear term like 5x. So you have to insert zeros here. It's very careful. So you'd have the coefficients are 1, the missing 0, x cubed, minus 26x squared, plus 0x, plus 25. So you add, multiply by 5, add, multiply by 5, add, multiply by 5, add, multiply by 5, get 0. Therefore, the remainder is 0, and 5 is a 0 of g to the x. So you can say that, in fact, x minus 5 times 1x cubed plus 5x squared minus x minus 5 is, in fact, when you multiply these two together, you would get back to the original. This is the beginnings of factored form. 5. The answer here is yes. Yes, 5 is a 0 of g of x. Determine whether the imaginary number I is a 0 of f of x. Sometimes we dip into imaginary numbers and sometimes we don't, but here in this problem it's very similar. Here's f of x, and x cubed, 1x cubed minus 3x squared plus 1x minus 3. There are the coefficients, and we're going to see if I is a 0. If you plug in I into f, will you get out 0? And it's actually pretty complex to do, I cubed and minus 3i squared, all that stuff. It might be a little easier with synthetic division. Anyway, add, multiply, add, negative 3 plus I. They're not like terms, they don't combine. And then you multiply by I. That's a little tricky, but you can still do it because I times I is negative 1, and I times negative 3 is negative 3i. Add, then negative 1 and positive 1 cancel, you get negative 3i. And then multiply by negative 3i to get positive 3. And when you add these two, you get 0. So yes, it is a 0. And so you can even write x minus I, parentheses, x squared plus negative 3i, x minus 3i. If you were to FOIL these, you should get back to the original. But we're not gonna. We've just figured out that, yes, it is a 0. Do you know where I went for my honeymoon? I went to San Jose, Costa Rica. It was the capital of Costa Rica. It was a lot of fun. And if you've ever been to San Jose, then you should tell me about it. The factor theorem, here's another application. For a polynomial f of x, if f of c is equal to 0, then x minus c is a factor of f of x. We've already been using that. So let's use it here. We're not given what the factors are, so let's try and factor it and solve the equation. F of x is equal to 0. Let's try f of negative 1. Maybe negative 1 is the 0, so we put it into synthetic division. You can see we've got the 1, negative 3, negative 6, and 8 here. And then we're going to bring it down, multiply, add, multiply, add, multiply, add. Nope. Since we get a remainder of 10, then we know that negative 1 is not a 0. So, here. Oh, and by the way, this is a house that my son drew. F of 1 is equal to 0. It will not be on the test. Let's try and see if 1 is a 0 of the function. Let's see. We've got our coefficients. 1, negative 3, negative 6, and 8. And so we add, multiply, add, multiply, add, multiply, add 0. Yes, good. So since 1 is a 0, that means x minus 1 is a factor. And we take the coefficients 1, negative 2, negative 8, and write the polynomial, the resulting the resulting factor polynomial. And I want you to take it one more step and figure out what is this going to factor into. You should have x minus 1, continue to factor it. Here. After you continue factoring it, I just want to connect the concepts. So let's say you've got a function, and it's either written, here's the particular function. It's in factored form, it's in polynomial form, and its graph. You can make the following statements. And you can make them for any one of these zeros, but we'll just take the 0 of negative 3. First of all, negative 3 is a 0. F of negative 3 is equal to 0. Negative 3 is a solution of this. Like if you were to take all this and say it's equal to 0, negative 3 would be a solution. Negative 3 comma 0 is an x-intercept. Bam. 0 is the remainder when f of x is divided by x plus 3, or x minus your 0, negative 3. And then x minus negative 3 or x plus 3 is a factor of f. You can make similar statements about negative 1 and 2. These are all the things that you can say if you know the zeros. Zeros and intercepts and solutions and remainders, they're all very intimately tied together. And you should be able to navigate them all. So let's start 4C2, copy the problem list, and then do the first problem. And I'll see you in class.